with answers. All right. We have one more. How many minutes do we got left? 20. We're going faster this class than last class because last class I did this in 4 minutes. All right, so now you have 20 minutes to do this one. All right? So what are we trying to do? It's going to be part of quicksort. And remember, back then they were really keen on getting it to be fast, right? They didn't want to be moving things because moving things is, you have to access disk. Moving is slow, right? So what is our problem? The input is a set of numbers and a pivot, which we'll learn later is chosen randomly. And what is our goal? Our goal is to put everybody who's smaller or equal to the pivot on that side. And on this side, we put everybody who's bigger than equal. Well, if they're equal, you get to choose. You don't only put it on one side. You choose where to put it, and the pivot stays in the middle. Right? Everybody good with the problem? And so the algorithm is clearly order n time, right? Clearly the algorithm is you look at the objects here in some order, and when you get an object, you throw it in one bin. All right? So that's it. Right? That's the algorithm. But if we're going for, can we refine it to make it fast as possible? Right? Remember those puzzles with 3 by 3 and you move the pieces around and there's one hole? Right? You try to get them sorted. That's what we're going to do here. We're going to try to get them. All right, so we need a loop invariant. And the loop invariant is going to clearly it's going to have to say, where do we put the smaller ones? Where do we put the bigger ones? Where do we put the guys who we haven't looked at yet? How do we store them? All right? And so our data structure is the smaller ones will be on this side. The bigger is going to be in this side. The ones you haven't looked at are going to be in the middle. And we're going to have a hole. And why do we have a hole? So that we can move things. And why is there how do we get a hole? We took the pivot out. Right? So it gave us our hole. And the loop invariant is going to say either the hole is on this side or the hole is on this side. And, of course, you remember which. Right? So you're remembering you have an index here and an index here, and I suppose an index here to tell you where these things are. Right? Everybody good with the loop invariant? All right, so now we want to think about how to make progress. Right? So if we're in this situation, we're going to take one of the numbers that we haven't looked at and compare it with the key and put it in one side or the other. All right? So if we take the 25, and if it's smaller, then what do we do with it? We just put it here, and that seems to be okay. If it's bigger, what do we do with it? We have to get it over here, which is hard, right? We don't want to get it over there. That's a problem. So what do we do instead? Any ideas what we do instead? We could swap, right? And how do you swap? You take this, you put this in, you put this in. That's 3 movements. And you know we don't like that, right? So instead, we're going to compare the 14, right? Why? If the 14 is smaller, we put it in the hole where it belongs, and it creates a hole here. And if the 14 is bigger, we leave it where it is, right? Pretty nice. So that's what we do, right? Everybody follow that? Right? You're seeing here, we compare it to the 14. 14 smaller, we put it in the hole. That's nice. The 14 is where it belongs. Oh, we got a hole where we accept that there's a hole over there, right? See how in one comparison, one movement, we've maintained the loop invariant, right? Everybody good? So there are a bunch of cases, right? If the hole's over here, you look at that one, and if it's smaller, you put it in the hole. And if it's bigger, you leave it where it is, right? And if the hole's over here, you compare with this one, and if it's smaller, you leave it where it is, and if it's bigger, you put it in the hole, right? It's pretty nice, eh? Everybody follow this algorithm? And so there was one point, and that's how do you begin, right? You take your pivot and you create your hole, right? So here, this is everybody that's smaller. Here's everybody that's bigger. Here's my hole. That's how I begin, right? And in the end, here are the smaller guys. Here's the biggest guy. There's my hole. What do I do with my hole? I put my pivot in, right? And then if you know quick sort, then I recursively sort that side and that side, right? And quick sort is supposed to be the fastest algorithm in terms of big constant. All right, everybody good with that? And, right, so some people in the old days wanted me to trace things out. So you can say, well, yeah, what am I doing now? I compare it with the 23, put the 23 in the hole, take the 82, put it in the hole, take the 79, leave it where it is, take the 30, put it in the hole, the 25, leave it, the 31, leave it, the 98, put it in the hole, the 14, put it in the hole, right? The 80, 62, you put it in the hole, and we're done. Everybody good? All right.